Sākam noslēdzot šo daļu.
Let us continue our work. And we will hear about laser scanning and photogrammetry as the tools for modeling and documenting heritage sites and objects. And next speaker will be Marcin Gladki from Norway.
Is it working? Huh? Thank you very much for the invitation. I have two impressions at the beginning. I would like to avoid the mic, but thank you very much for the invitation. And as I said, I have two impressions at the beginning. The first, it's of course, I wish I could have joined the group before. That's the first thing. And the second thing, that almost, I guess, everything has been already said over here, and they will be a little to surprise you. So basically my presentation will be divided into two parts. At the beginning I will focus just on some kind of a methodological aspects, and in the second part I will show you some implementation. And this will be, well, the third impression is, after what I've seen, is actually that there is no universal tool for document everything. So, and our toolbox that we have at our disposal is growing rapidly year by year. So let's get started. So I will start, of course, from the older sister of laser scanning, which is the photogrammetry. And I am using, until now, the stereoscopic photogrammetry. I am using the single pictures photogrammetry in some certain cases. I will show them later on. The point is that here in the stereoscopic environment I have actually better control on the area of interest, and I have really a much better possibility to calculate precisely what I want to achieve, basically the level of detail. So for this type of photogrammetry you need, of course, the two pictures, left and right pictures of the same object. And then you just plot the three-dimensional shape and put the 3D surface, the triangular irregular network surface, on that. We call it the mesh. And the mesh, of course, can be texturized, so the image data can be placed on the mesh. And of course, when you do a surface by surface, you can achieve quite a good results and build your 3D models, starting from the small ones up to, of course, the more complex scenes, like you can see here. This is actually an example from medieval monastery at Halsnøy in Norway. What I was thinking about the better control is actually I have, when I am doing it surface by surface, I have actually ready surfaces to produce the 2D documentation, which is, of course, we all would like the three-dimensional models and environments to be used widely. But as far as now, it's still the 2D that is most commonly used. So in that case, I can quickly produce the ortho images. Ortho images are the images that have all the characteristics of the map, so you can just make the measurements upon them, and of course extract the necessary vector data. The vector data, of course, are still needed for many purposes, starting from the people that are doing the office work and working on that directly in the offices and institutions, then all the people that are working during the restoration. They just need a kind of a background to do their own analysis there. And of course, all the people that are working in the GIS environment, they are still mostly, 99%, they are working in the 2D environments, because the 3D is entering into GIS, but in case of the huge data sets like point clouds or huge 3D surfaces, heavy files, it is still yet to come when they will be fully adopted into the GIS. Oh, okay, it's not that arrow, I'm sorry. Okay. Yeah, it is that. Okay, we can apply the same methods to the smaller things, of course. In case we need just a rough metric survey and for the archaeological documentation, and of course some kind of a 3D data to, for example, to publish it on the websites or just for some kind of the educational purposes as well. So we do the same thing. So we create a set of pictures, a network of polylines, and then create the 3D surfaces. All depends, of course, here on the quality of the lenses, quality of the camera, the size of the sensor that the camera has, and the number of pictures. But of course, the results are not so extremely accurate like in case of the very detailed scanning, but they are still good enough to put the object into the further post-production, because to make the file very usable for many other environments like the animation, rendering, and publishing, we can easily make the retopology of this geometry and create it with the same quality, but with the decreased level of polygons. And that's the retopology results. So in that case, I am converting the triangular surfaces into quads, which are the standard in most of the rendering, animation, and presentation industries. Here is a kind of a comparison between the quad cage and the high density surface, which is down below. And this kind of a retopologized data can be easily texturized, rendered, projected, and used for create a basic documentation with enough accuracy for everyday archaeological use. This is, of course, the example of the Bruges from the Roman period, which is, it's actually 3rd century AD. And of course, this kind of environment gives us a power, the whole power of reconstruction. So we can reconstruct the objects, how they looked like, and of course, model the elements that were not existing when the items were excavated from on site. That was the needle over there. Laser scanning, of course, it's more or less common. Has more or less the same characteristics like the photogrammetry in case of a methodology. So you have some kind of a point clouds that you have to register. I mean connect together several scans, like you see here, the chain. So you make a series of scans to have a best overlap that you can achieve, and then you build the 3D model. This is called the scans orientation. As it's been said already, the scans can have their own reflectivity colors. They can also have the RGB colors. And recently, they can also have, for example, the thermography values. Yeah. And of course, if we are working in the same coordinate systems with the single structures, we can connect them together and build the more complex models. As it's also been shown, the best way, one of the ways to create the documentation is cutting the cloud. And this is actually where I am using the laser scanning, the large scale laser scanning mostly, because it allows me to create very quick sections comparing to photogrammetry. It's much easier than with the photogrammetric surfaces. And as in case of photogrammetry, the laser scanning gives you the possibility also to create the ortho images. But as it's also been pointed out in the Nidaros, the quality of the ortho images from the laser scans is not good enough to create good documentation of the stonework, for example. You can, of course, tweak with the lighting. So, because the point cloud is a three-dimensional data set, so the way you put the light on that, the different results it will gives you. So sometimes the type of lighting will allows you to express more details on the surfaces. That was also said that the observation in RGB are actually the less gives you the less value comparing to observations in grayscale or other types of shaders. And also, scanning data gives you a possibility to do the comparison studies. Yeah, so you can compare, as here, scan data with the photogrammetry data. And of course, as it's also been pointed out, which is a good value, it's becoming a good monitoring tool. So if you are doing some scanning sessions in time, you can compare the scans between each other and create that kind of a deformation maps as well. The same thing, the same rules applies to smaller items. This is an example from the Norwegian buildings taken out from United States, actually. It's the wooden dragon from the building that was a part of the World Exposition in 1896. It's been taken home to Norway last year. So you are making a series of scans, then you are just orienting them together and fusing into a model. Normally, in everyday work, I'm using the scanners from 0.1 to 0.5 millimeters when I'm dealing with the smaller items, and of course the standard ground terrestrial scanners for doing the architecture, which means I have one phase-based scanner, which is faster simply, but it's good for operating in a short distances, and I have one pulse-based scanner, which I use outside because it's a little bit slower, but has a greater distance, and it's also has all the characteristics of the total station, so I don't need to register the scans together. And again, when we have a fused 3D surface, we can just texturize it and render the way we need. And let's follow quickly through some projects here. And we have the Runepiner, the rune sticks from the excavations in Bergen in the 50s. So the method was photogrammetry, but the purpose was not the documentation, but actually to support the website catalogs and virtual collections, and of course to put them on the touch screen as a part of the exhibition. And that's the rendered or the screenshots from the 3D space, how they look like. Normally, I'm using actually the model software, which is I think best subdivision surface, or actually the polygon modeling software now on the market. It has also some sculpting capabilities and painting, but it's not as good as the zebra chase. So, but it's in one single application. So. And that is supposed to be just, yeah. And of course, we just normally we can simply render those items into the animations and present them wherever we need. And other types of objects, those are the bake plates made of stone with visible tool marks. And the purpose of the project was basically to do the documentation, which was the part of the PhD of one of the archaeologists. And the other was to make also the website catalog and the virtual correction. And that was done by the photogrammetry as well. Here there are some 2D extractions. And again, the whole power of the 3D is that we can just collect the items into a virtual space. The items that normally would never been collected together, they are in the different places, in the different parts and the different museums, and just also nicely publish them. Okay, so our items grows bigger in here. Again, another project just to create a digital collection of the basic tools used in the 19th century in the cluster farm at Havra. This is in Hordaland in Norway as well. So the basic tools for dealing with grain, basically. So here the examples of the model. The method is again the photogrammetry and some final results. Okay, and this time it's running. Well, I will not be saying much about the accuracy of that because I assume that everything has been already said, and it could be a subject of the different seminar actually. But I assume that with the laser scanners that we have now, we can achieve whatever we want if we have all the types of the equipment in our toolbox. Yeah, so as it's been shown in case of the boats, we have extremely accurate scanners. We can deeply go to a structure. But normally, not all the objects are necessary to be documented with such a precision. And again, some example of the virtual corrections. So we have sickles down there and the rest of the farming tools on the top. And here we proceed with the examples of scanning. So those are the items from the migration periods, actually, from the excavations. And they have been scanned with the scanner, which has the 0.1 millimeters precision. So it's twice less accurate than the scanner used in case of the boat. Well, but for the common use, for the archaeologists or for the presentational analysis, it's, I guess, absolutely good enough. It should be another movie over here. Yeah. So that's the. It's actually it's also a brooch from the late 8th century. It's quite of a kind of a small item, not more than 3 centimeters in length. And again, finally, the collection of things that can be visualized and published separately or together on the website. So then we increase the size of the object and we proceed to the boats. And this is an example of the project of the 19th century boats from Bjørsvik. And here, the purpose was to create a basic documentation and also to support the exhibition at the museum to show how the boat is constructed. So here, actually, the photogrammetry was also used. So based on the photogrammetry, just created a schematic model that can be used or for simulating, animating, and also as an educational element at the exhibition. Some kind of 2D extraction of the photogrammetric data over here. And we are getting back to our wooden dragons from the building from Chicago, from the World Exposition. And here, because of course the elements, the building was originally dismantled in Chicago and then put back in the parts to Norway. So it was necessary to create a parts catalog before the final reconstruction. So here, because the objects are much bigger than these archaeological items, the 0.5 millimeter scanner was used. And here you have some final results of some roof framing elements on the right. Yeah, and here some columns, pillars, and base timber of the timber frame. Well, there is nothing against combining the technologies together. So here we will have an example of the photogrammetric survey of the building, wooden building. And everyone that is using the photogrammetry knows how difficult it is to properly document the wooden framing. I mean, all the roof framing and joists and everything in that kind of a building. So we can just combine all the technologies together and also create a nice documentation for further use. The same thing concerns, of course, the other buildings, other types of buildings. So normally, until now, we all, I mean, maybe not all, but most of the people that I deal with, they simply need the drawings. So the photogrammetry is still a better way to do them instead of the laser scanning. And here another examples of the combined project. This is the ruins of the medieval church. Also, this is the Stein in Norway. And we have combined both technologies. So here we have the view from the scanned model space. And here we have the meshing. So the surfaces are on the object. And again, the 2D representation of the model. Sometimes we have to use both types of techniques again. So here you will this is the heritage dam from the beginning of the water power plant revolution in Norway. And it's actually the purpose of the project was to do the documentation before the demolition. So the first, of course, I used the UAV mounted photogrammetry system. So it was the drone flying over here. And of course, in that case, the single pictures measurement algorithm was quite good. I mean, the series of overlapping pictures, like the Agisoft photoscan or many more, Pix4D, for example, or another type of that kind of an application. And this is the perfect way to use it, just to create the DTM and a rough model of the object from the top. But here, inside we have a very regular wooden pattern from the very straight timbers, and that's the place where photogrammetry actually failed. So the scanning was definitely the better solution to do the documentation of it. So I used both type of scanners. The phase one to have a coverage of the insides of the arc and interiors of the pillars, and the pulse base to have the top from a little bit further distance. And again, the structure model has been created upon that scans. And a set of technical drawings, because there was still a need for that and a demand. Sometimes it's the best way to have 3 types of methods or 3 different capturing methods and use them in one session. So this is an example from Stavanger. This is the Domkirke, and I had the pleasure to document the eastern facade and the towers. So it was again pointed out, the best way to create a documentation of the stonework was again the photogrammetry against the scanning, but in the smaller chapel I used the scanning with quite a good results. And of course, again, when it comes to details, I simply climbed on the lift and just did all the sculptures with the 0.5 millimeter laser scanner, just to have a better or the best possible results. And of course, again, the ortho images and the drawings are necessary for the people that are doing the conservation over there. And other examples from Bergen, it's also the photogrammetry. So here we see the vaults of the Maria Kirke. Some combined sections done by photogrammetry. And I also started to go into the VR market. I mean, because this is probably the kind of a solution that will be viable near in the future. The VR engines, they have a ability to import the extremely large data set and operate quite smoothly with them. So when you put the photogrammetry or scan data over there, together with some nice atmospheric effects and some city modeling over there, you can create a good environment for maybe not only even education, but maybe also for the documentation, because you can easily program the points of interest on the model that you can attach the data you are interested to load. And here, finally, some example of the VR. Yeah, so those white, those are the strings of text that you are getting when you are touching the element when wearing the 3D glasses over there. So to summarize somehow, well, I think already has been said and done, but I just repeat what I said at the beginning, but there is no universal tool for making documentation, and everything depends on the type of object, the size of object, the field situation, and of course finally the purpose of what the documentation has to be created for. Thank you very much.
Paldies, Marcin.
Thank you very much. Do we have any questions? Then I would like to thank you all for being so patient, being so attentive, and I would like to thank all the speakers for very exciting presentations. And I think that from this seminar we will bring home much inspiration, many ideas for new developments, maybe some unorthodox approaches to what we do. And what we can conclude today, and what Marcin already mentioned, namely the 3D scanning and surveying, first of all, is a great value to the research and also methodology of preservation and conservation. And it is also a great tool to actually promote cultural heritage, because it allows us to publish the images. It attracts attention of general public, and it creates new opportunities to finally see what has been concealed from us in the past. And I think that this is really great, and this is something that may inspire people to learn even more, and then to put an effort to preserve this heritage also for the next generations. In other words, we are promoting the availability and accessibility to our heritage. So the State Inspectorate has conducted surveying of 29 sites. The results have been submitted to the owners of these sites or objects, and now they have been transferred to the relevant architects who are in charge of renovation works. So, generally speaking, I would say not always people have been very responsive, or not always they share our opinion about whether such surveying is necessary at all. And therefore, it's also quite interesting for me to learn from you whether you have had some practical experience with this new way of surveying, whether it's just a Or is it enough for us to simply be happy about other people using these 3D technologies, but let us do it manually? So do you have any opinions? I would say that these technologies are quite revolutionary, and they definitely will be helpful in our future work, and they will help not only for those who do the restoration, but also for architects and other involved parties. So I would like to say that this is the technical revolution, and I'm truly impressed with what I saw today. And it's great that our colleagues are having such great time exploring these new technologies. So I think in future we will be working closer with technical experts. And I also thought that we could probably complete the scanning, and then based on the scans, we could provide recommendations for the owners of these sites. That would be really great. So I'm looking forward to these technologies developing also in the future. So thank you very much for this seminar. And this may also lead to another topic or another conclusion, namely how important it is to cooperate closely with between the heritage experts and technical experts, because the heritage experts may actually define the task while the technicians would be in charge of implementing it. And I would like to ask my Norwegian colleagues whether you have already compiled some kind of list of success stories related to the 3D scanning.
The simple answer is no.
Tas ir mierinājums.
It's quite comforting for us. It means that we are not lagging behind so far. But do you also know some other owners of the sites who are using this methodology, or some architects that were not mentioned today? Maybe in the future, yeah.
People in Norway doing both laser scans and also geophysics, and we also see that we have several archaeologists doing geophysics and not engineers doing it. And I think that can be an advantage, because often if the technicians are controlling the process, you get huge amount of data and people are asking why. It's nice to look at, but why are we doing it? So we have several companies and county administrations doing these sorts of things, but it's often up to the kind of people that are employed, if there are technically interested archaeologists and so on.
Yeah.
Well, I'm from the Directorate for Cultural Heritage, managing conservation viewing. So we work together, Marcin and I. And we have a very simple, also a simple way of using it, because we do the printing of the 2D. We have been talking a lot of the 3D documentation, but the 2D result is also very important for us because we can give that directly to the masons. And when the masons destroy their paper, we make a new. So it's a very direct and simple way of using it, and it's always correct. And it's a very good tool for them. So they are really using that.
I just wanted to ask my Norwegian colleagues, because I was just recently attending an award ceremony where Norwegians received this King's Road. And I just wanted to ask you whether this King's Road between Bergen and Oslo, whether in this renovation work also this 3D scanning was used, because I know that they renovated not only roads but also bridges. It was a huge project, and they truly deserve this main prize of the competition. But did you also use this 3D scanning in this project?
I don't have an answer for your question, sorry, but this the last weekend we had in our workshop in Trondheim, we had a blacksmith festival. It was 60 blacksmiths from around coming and having fun and making nice things in iron. And I met one man from California who actually was making a photo scan of when he was blacksmithing. Every time after he was doing the craft, he scanned it and then into the oven again. And he did this to show how actually the craftsman did hit the iron every time in between. So it can be used like a way of showing craft, actually, how it's done.
This.
I will continue what Mr. Gailītis did, so I would like to ask my Norwegian colleagues, taking into account that here we heard mostly about 3D scanning and those possibilities, we did not touch, or I do not know, what is Norwegian experience about using radars in scanning cultural layers or different objects in these cultural layers, especially what could be topical, or it is a question of interpreting. We have to check this with regard to burials. So when you do something like that?
Well, there are several county administrations doing ground-penetrating radar as preparation for prospection archaeology, like if a large road is to be built. But it's mostly experimental, and as the geophysical guys always say, you anyway have to dig to check if it's actually something or if it's nature, because it doesn't seem to be that precise on what is cultural and what is not, but it's an indication. So several of the more technically advanced county administrations are using geophysics combined with the digging when there's large things being built.
On this.
Thank you. It seems that we do not have any other question, and tomorrow we will have practical work. So to see how it works in real life. And of course, today's technologies, modern technologies, cannot replace traditional crafts and skills and knowledge but they can help us, of course. I think that in a modern culture, we will use more and more virtual reality, and we have all this virtual and material reality goes hand in hand, and we as protectors of cultural heritage, we have to use all this, we have to follow all this development, and nothing will change for worse. Of course, everything will change for better, and we will be able to use those technologies more and more, and it will be more and more advantageous for our work in preserving cultural monuments, so we can create a better and better living environment. I would like to thank you all for today's work, and let us meet tomorrow at 10 o'clock next to Three Brothers building.